Hello everyone and welcome back to our course. In this lecture, we are going to learn how we can make more data frame queries and also how we can add filters as well. Okay, so first let's start by learning how we can use the filter function to count a certain query. For example, what if we wanted to only look for the number of days where the volume was less than 200,000, or in this case, about 2 million rather. Let's make a query for that. Okay, so I am going to use the same data frame and I'm going to use a filter function. I'm going to filter where the volume is less than 2 million. All right, and what I can do is filter that and then grab a count from that result. And then if I run this code cell, I get the value 1006. So that is how many rows have a volume that is less than 2 million. We can also query how many have a volume greater than 2 million, and that's 253, so the difference. All right, and another way to do this also is to grab the column from the data frame itself, but it's a little more messy, but I can show you. We can use the filter function again, then we can grab the data frame at its volume and then check which is less than 2 million. Okay, and then we can grab the count from that. So that is another way to get that result. But it's a little more messy, so it's much cleaner to just pass in the string query. All right, and we can also create a little table out of this. So for that, I'm going to grab my data frame and filter where the data frame at the volume is less than 2 million. All right, and then I can grab that result and I can select from it a count of my volume and call the show function to show the results. In this case, I do have to import count from pyspark.sql.functions. We're going to import that count function. So it's different from using this built-in count function. If we're using the SQL function's count function, then only then can we pass in directly here this result. So then if I run this, we now get this little table because the result is going to be a data frame that's just been filtered. So here we now have a filtered data frame. All right, and this data frame contains a header which has count volume, and we have 1006 as the result. And this is just a third way that we can count the number of times that a certain filter is passed as true. All right, next up, let's add a bit more math into our queries and our filters. So I'm going to this time check what percentage of the days was, let's say, the price of the stock greater than 1,000. All right, so let's make a new code cell to answer that. I'm going to grab my data frame and filter it. I'm going to filter it where the value of the stock, let's say the open value, was greater than 1,000. I'm going to call that filter and then wrap that. Then I'm going to append the count function to get the number of times. And if I want percentage, I'm going to multiply by 1.0 to get a float and divide by the dataframe.count. And then I am going to, after that, multiply by 100 to get the result as a percentage. All right, and let's see. Let me just make sure here that your parentheses are exactly as I have it here. Because what we're doing is first we're performing the filter and then getting the count. Then we have to multiply by 1 and divide by the count. That is so that we can get that percentage as a decimal, and then we multiply by 100 to get the actual percentage as a percentage. And if I run this, I am going to get 65.13. So that means that the value of the stock was over 1,000 65% of the time. Another thing we can do is we can also find correlation. So let's do that next. Let's find correlation between different columns. All right, so for that, from pyspark.sql.functions, I have to import the function core, which is short for correlation. I'm going to call dataframe.select, and I'm going to select the correlation of two of the columns. For example, let's do open and close. All right, and then I'm going to call show to get my results. And when I run this code cell, we see the correlation between open and close. So we can see it's almost 100% because typically the opening and closing price of a stock is going to be quite close. But if we try something else, like if we do open and high, or even high and low, that would be interesting, then we can compare the high versus the low of the stock every day. And the correlation, okay, about 100% again. So not much difference there. We can try as well open and high. Don't expect much of a low correlation. Nope, pretty high. If we do something like open and volume though, we're going to get a vastly different result. Look at that. Now we get 0.02. And that's because open versus volume, those two values are quite different. Because open, of course, is the value of the stock, but volume is the number. All right, so that is how we can find correlations between different columns. We can also find values per a certain category. For example, we could group our columns, and we could get the maximum or the average or any minimum of one of the columns, like open, per every single year or month or even decade. So let's look at how we can filter one of the columns per year. So from pyspark.sql.functions, we're going to import year. And we're going to grab our data frame and we're going to add a column to it known as year. Now to convert a date to a year, all we have to do is use that year function and pass in the column of date, because that is going to be a date here, and we can just easily convert that to what year it was. The result of this is going to be our data frame with a year. So we'll say data frame with year. All right, then we can call data frame with year and we can show it. I'll run this code cell and look at this. Now we have our table, our data frame, and we also have this extra column in it called year. All right, great. Next, we can now put that year to use. So we can group all of our values by year. For that, I'll take my data frame with year and I'll use the function group by. I'm going to group by a column, in this case year. So that will take all of the values in year that are the same and it will group them. It will group those rows. All right, and then I can call show here to get my results. Let's see, that's going to be actually group data, so we can't grab show, but we can still run this. And yes, we can see here the result is going to be a grouped data type. So what I can do, for example, is get the max from the group, which will be the most recent year. Okay. Now, if we want to actually show this, we're going to select it. So I'm going to add a new code cell, and I'm going to grab my data frame or my result here. Let's grab our max, and we'll store this as max year data frame. Then I'm going to take that max year data frame and select from it the year and as well the max high. So I want to get the maximum of the high price of the stock. Then when I run this code cell, we just have to make sure we first define that max year data frame. So we have to run that previous code cell. And then look at this, we get all of our years here, and they're ordered by the maximum value of the stock at that year. So 2018, 2019, 2020, 2016, 2017, and 2021. Okay, yes, so they're not really ordered actually here, I noticed in the max. They are in random order, just however they may appear. All right, we can run this again. And we're going to see we get, again, just this same order. All right, let's see, what else maybe want to do here with our queries. Now that we have been able to take the year and grab the maximum of that year, we've been able to successfully group our table, our data frame, into years and then grab the maximum of the high column from each year. Finally, let's do one more practical example. We're going to learn how we can find the average for every month. All right, so for that, I'm going to have to, from PySpark.sql.functions, import another function known as month. All right, and I'm going to grab my data frame and add another column to it. The column will be called month, and I'm going to, as well, into that column, put in the month function with the date column passed in. So that means I'm taking the date column and I'm converting it from a date to a month. And that will give me a data frame with month. So it's similar to how we just did. We made a new column for the year. But this time we're making a new column for the month. And we can now call data frame with month dot show, and we can show the results here. Okay, there we go. We had this month. The month is going to be an integer corresponding to the month out of the calendar year. All right, next, what we can do is we can group our elements by month. So we'll take our data frame with month and we'll select from it the month. Then we can get some value of the stock again, like the high. That will give us the high column, and we can group it by month this time. All right, and then we can run this code cell, and again, we get grouped data as a result. And we can find the average by adding the function mean. That will return a data frame this time, which is the average of the months. If we append show here, then we can show a table. We have every month, and it's just in random order. And we have the average of the month column, which is just the column itself. But then we also have the average of the high. So that's the average high value of the stock per month. All right. And if we don't want to show that average month, then we can just remove that from the query here. Okay, let's take that average and let's store it as the average of months. So I'm just going to copy this again, add a new code cell, and just instead of showing it, I'm going to store it. I'm going to store it as average months. All right, and then I can use that data frame. I'm going to grab average months, and I'm going to select from it the month, and I'm going to call the average of the high column. Following that, I can then order it by a certain column, like month. And let's call show to show that. And we'll run that code cell, and look now, okay, our table number 1 is ordered, which is good. So now we're ordering it from 1 to 12, January to December. And we also have the average of the high column at that month. So the average of the high value for January, the average of the high value for February, and so forth. We can do this for any column we want. For example, we could replace this with instead volume or open or close, and it would just give us the average of that column instead per month. Awesome. So in this lecture, you learned a lot of valuable and slightly more complex queries and filters that you can perform with Spark. These types of questions are commonly asked at the programmer interview, so I definitely recommend practicing more examples if you're aiming for that new job. Congratulations, everyone, and I will see you next time.